Hello students. So today's topic is queues. Queue is a linear data structure where insertion and deletion take place at two different ends. The end where insertion takes place is called the rear and the end where deletion takes place is called the front. So this is a first in first out data structure. For example, the persons waiting in a queue in a bank, the automobiles waiting at a red light. These are examples of a queue. So a queue is a linear list of elements in which deletion can take place at one end called the front and insertion can take place only at other end called the rear. The term front and rear are used in describing a linear list only when it is implemented in queue. So the term front and rear are only used in queues. So queues are also called first in first out list. Since the last element in a queue will be the first element out of the queue, we can also call this FIFO list or first in first out list because the first element which entered in a queue will be the first element which will be out of the queue. In other words, the order in which element enter a queue is the order in which they leave. So the order in which an element enter a queue is the same order in which they leave the queue. This contrasts with stack which are last in first out list. So this is opposite to the or stack which we studied earlier, which is last in first out. Means the the element which enters last in a stack is the first element which will be out of the stack. So queues, examples of queues are queues around in everyday life. The automobiles waiting to pass through an intersection form a queue, in which the first car in line is the first car through. The people waiting in line at a bank form a queue, where the first person in line is the first person to be waited on, and so on. So an important example of a queue in computer science occurs in a time sharing system in which programs with the same priority form a queue while waiting to be executed. So in computer science, an important example is in a time sharing system. For example, a hardware or software is used by different CPUs. So if all the CPUs have all the programs have same priority, then they will form a queue, and the program which requested first for that hardware or software will be executed first. So representation of queues. So how we represent in queue? So for example, you can see here we have a queue. Its size is n, and we have four elements in it. So the value of front is 1 and value of rear is 4. If we deleted an element from this, so value of front becomes 2 because if we have to delete an element from the queue, we have to increase the value of front by 1. So value of rear remains 4. So if we have inserted two values EEE and FFF, so value of front remains 2, but value of rear becomes 6. So we have again deleted a value BBB. So here again you can see the value of front becomes 3 and value of rear becomes 6. So we will explain this in next slide. So the figure which I indicated the previous slide indicates that the way elements will be deleted from the queue, the way the new elements will be added to the queue. So we have explained how we can delete the elements from the queue and how we can add the elements into the queue. Observe that whenever an element is deleted from the queue, the value of front is increased by 1. This can be implemented by assigning front equal to front plus 1. So when a value is deleted from a queue, so value of front becomes increased by 1. So here the value of front is 1. So AAA is deleted. So value of front becomes 2. Similarly, when an element is added to the queue, the value of rear is increased by 1. This can be implemented by assigning rear equal to rear plus 1. As indicated here, so we have value of rear 4. So we have added two elements EEE and FFF. So value of rear now becomes 6. So whenever a value is inserted in a queue, the value of rear will be increased by 1. That is rear equal to rear plus 1. So when rear equal to n, we insert item into the queue, then we reset rear equal to 1. And if front equal to n, then an element of queue is deleted, we set front equal to 1. So how this we explain in the previous figure. So if the value of rear becomes n, so if we insert an element, we will not do n equal to n plus 1, but we simply assign the value of rear to 1. And similarly is the value of front. If the value of front is n, so if we delete a value from the queue, so the value of rear now becomes 1. Suppose that our queue contains only one element, that is front equal to rear equal is not equal to null. So if your queue only contain one element, then in that case our front will be equal to rear, and that will not be equal to null. And suppose that element is deleted, and if we delete that single element from the queue, then we say front equal to null and rear equal to null to indicate that the queue is empty. So when front equal to rear and they are not equal to null, it means we have only one element in the queue. And when we have front equal to rear equal to null, it means we have an empty queue. So we will take an example here. Here queue is empty, so front is 0 and rear is also 0. So we have inserted three elements. So front becomes 1, rear becomes 3. We have deleted one element, front becomes 2, rear becomes 3. We have inserted two more elements, front remains 1 and rear becomes 5. We have deleted two elements, so front becomes 4 and rear is 5. So we have inserted another element, so front remains 4 and rear becomes now 1, because after n it will go to 1. So we have deleted one element, so front becomes 5 and rear becomes 1. So we have inserted two elements, so front remains 5 and rear becomes 3. So we have deleted one element. Here front is n, so it will become 1. So front becomes 1 and rear remains 3. We deleted one element, so front becomes 2 and rear remains 3. We have inserted one element, so front remains 2 and rear becomes 4. We have deleted two elements, so front equal to rear equal to 4. So here front equal to rear, it means we have only one element in the queue. So we have deleted this element. So here front equal to rear equal to null. So our queue is empty. This is how queues work, and how we can insert and delete elements in the queue. That's it. This is I have today about queues. Thank you.